Okay, so in this video, I'm going to uh, solve the pneumatic circuit of the homework 6. And in this homework, so you're supposed to do that, but I'm going to show you how to use Festo FluidSim by working on this homework. So we are going to have one indirect control of double acting cylinder. So we have a double acting cylinder and we need to have indirect control. Positive control signal is going to be automatic and negative control signal should be automatic as well. And the main valve type is 5 by 2. So I already provided this solution here. So the main purpose of this video is to show you how to work with Festo FluidSim. So I have the Festo FluidSim as I was provided the instruction on how to use and open the Festo FluidSim on Moodle. So hopefully you have that, so you could open the Festo FluidSim. This is the software environment. Now we are going to have a new project. So I'm going to click on new, and on this one I'm going to start basically drag and dropping my parts. So for the supply element we have a compressor, so I'm basically drag and drop it here simply. Now we have one double acting actuator, so here we have a double acting actuator. Then we need a valve. Okay, so directional valve. We need a directional valve, and this one is going to be a 5 by N. So this one is the default one is 5 by 2. So we need to have a indirect control, so I'm gonna basically use 3 by 2 valves here. Okay, and I think we have almost all the components we need. Now we need to start making our circuit. So I'm gonna start with the valve. If you double click on a valve here, you will see a window, and on left actuation and right actuation. For the right actuation, I'm gonna basically have a spring return. So you see, if I check this box, I could have one spring here or remove the spring. On the left actuation, I want to have automatic, so I'm gonna use one of these mechanical rollers and assign one sensor to that. Okay, so here you are. We have this one here. That's it. On the other one, again, I want it to be a spring return, a mechanical roller. For now, looks good. On this one, I want it to be pneumatic, so I'm gonna use basically a pneumatic control or actuation for the left and right. And that's it. Now for the basically exhaust ports, like 3 and 5 ports, we could double click. So you see I'm double clicking here on the dot. See, the color has changed to green. Double click on that. On the terminator, you could choose the default or simple terminator, or you could choose any of these symbols. This one is basically blocking the pathway and is not ideal. Of course, it's useful in some specific cases, but it's not ideal for us. You could either use this symbol, this triangle, or this one, which means simply exhausting the air to the atmosphere, or you could use a muffler. And it doesn't change functionality of the circuit, any of these three last ones. The muffler basically in a real circuit reduces sound of the air, or yeah, the sound of exhausting air to the atmosphere, and that's it. So I'm gonna go with the triangle here. Click, same same for the port 3 and 5. Okay, now we could start to connect our compressor. And before that, if you double click on the compressor, you will have characteristic of the compressor. So how much is the operating pressure of the compressor? You could change it. This is in bar, okay, and you have the equivalent one. Sorry, this is a megapascal. You could choose bar or psi. So let's keep it as the default one, megapascal, and the maximum flow rate, or liter per minute, or you could basically use a gallon per minute, the US one, or the UK gallon per minute, or uh, G per second. Okay, so we could continue connecting our compressor to valves, and then the main valve should be connected to double acting cylinder. Output of control valves will be used for this basically actuation, pneumatic actuation of the main valve. For the double acting cylinder, again, if you double click on that, you could change the type to single acting extension, or single acting retraction, or you could make it true. So you see, any changes will be reflected here in the symbol, and you could easily see if you've done a proper changes to the settings or not. So I'm gonna go with the true bar, because we will have a balance force on the right and left side of the piston. And see, for the cushioning also, you could change it. You see, it's a very good practice with the symbols, adjustable, non-adjustable. Either you want the cushioning or not, and the sensing, do you want a sensing or not? Okay, so I'm gonna remove all of these just to have a very basic, simple double acting cylinder. Other parameters, you see that you could change the maximum stroke here. This one specifically is useful to know how much is the maximum stroke when you want to place the sensors. So 100 millimeter is the maximum stroke for this case. The piston position, piston diameter, and other basically parameters also could be adjusted here. External load, you could apply some external loads. Force profile, you could design a specific force profile, or the monitor basically the force profile, and actuating labels. Okay, so I'm gonna press OK. Now I want to place sensors. Okay, so to place sensors I need a ruler. So the distance, you see here, we have this distance rule. So I'm gonna place it here um, on the bar of the double acting cylinder. If I double click on that, now you could place your sensors. The first one, I just want to name it sensor A, and this sensor A will be activated from 0 to 10 millimeters. So it will be placed at the beginning of um, the stroke course, and the second sensor B will be placed at the end. So the range of this sensor, or the range that this sensor will be activated, is from 90 to 100. Okay, I'm gonna press OK. So if you increase that range, let's say for the A, which is now from 0 to 10 to 0 to, let's say, 50, you will see that this bar, the solid bar, will increase. Okay, so now this one is increased. It means that the sensor A will be activated in this whole range. Okay, it's not ideal for us. The sensor should be activated only beginning and end in a very small range. Okay, so I'm gonna change it back, and be careful of also this range in millimeter. Yes, where this one comes from. This is basically the stroke course of the double acting cylinder here in the parameter. Okay, so maximum stroke, uh, yeah, so this one. Okay, so maximum stroke is 100. Okay, so you are allowed to increase it to 5000, but for our case is just 100 millimeter or 10 centimeter. Okay, almost done. Now we need to basically assign these sensors to these rollers. Okay, sensor A and sensor B. Okay, so based on the solution here, we have the sensor B here. Okay, and what is the reason? I will explain the reason later. Okay, so now let's analyze basically our circuit. What happens now? This chamber, this chamber here is pressurized. Okay, so this piston will stay at this at the left. Okay, this one is not activated because sensor B is not activated, but sensor A is activated. Okay, so this pathway will be open, and it will switch the circuit. Let's try it. So I'm gonna start the simulation and see how it works. Okay, so we are in a basically lock mode because the status of one of these this directional valves not correct. Okay, so we need to change that. So here, see what we have here in the solution. So we need to change this one. Most likely, if I change the initial position, that okay, so that might solve. But okay, I'm gonna basically, just for now, to avoid difficulties here. So you see how we could remove this one. Just click on the white part, and that will be removed. I'm gonna assign this sensor A back here. Okay, so this one should be sensor A, and this one should be sensor B. Yeah, it's okay. Yeah, because we want this one to be active. We want the main valve to be switched at the beginning. Okay, here you are. Okay, I'm gonna stop it. Stop the simulation. You see that and no way we could stop this circuit. We need to have a start and a stop button as you have it in another homework. So hopefully this video help you to start with a Festo FluidSim, and please try to submit all homeworks on the directional valve lectures on time.